carry on. So the reason why is you look here, 1 plus tan squared, 1 plus cotan, cosecant, secant, any of these. If you multiply 1 plus tan times 1 minus tan, you're going to get tan squared theta minus 1. You get a difference of squares, right? Which often is one of the consecutive pyramid entities that you can swap out. So you have to multiply by its conjugate. So I have 1 plus cos x here. I'm going to do it to this one because this one already looks kind of ugly. So I'm going to multiply this side by 1 minus cos x. Now, do you remember what I told you about the ones with the conjugates? You put these ones together, but what did I tell you about the ones that are not? Do not distribute. Like, I'm going to leave that 1 minus cos x sitting up there in brackets. And if you look, wow, it's already starting to look more like that one, isn't it? Now I have 1 minus cos x in the top, in here. So if I go distributing this into the sine and the cos, am I getting any closer to this? If I actually distribute this through? No, because this is 1 minus cos x and cos x. Now I have this and this. I just need that sine to go away. And then it would match, wouldn't it? On the top, in the numerator. So I never distribute the ones that aren't conjugates. So I'm going to get 1 minus cos x, sine x, cos x. And when you multiply conjugates together, the reason why you do it, and you did it in radicals last year, is because it gets rid of your middle terms. So 1 times 1 is 1. And then you get plus cos x minus cos x. What happens there? They cancel, right? That's why you use opposite signs. So I get plus cos x minus cos x. So they cancel. And then negative cos times cos is negative cos squared x, which is actually a formula off your formula sheet. What's 1 minus cos squared x off your formula sheet? Sine squared. So I'm going to get 1 minus cos x, sine x, cos x. And then down here I'm going to get sine squared x. And you have to watch, because sometimes it's like cos squared x minus 1, and if that was it, then it would be negative sine squared x. You have to watch how they rearrange the formula, right? You have to watch what you're given. But I know that if I move the cos squared over with the 1, actually, yeah, it's the other one. If I move the cos squared x over with the 1, I'm going to have a positive sine squared. Now this, let me use different color. This and this cancel, because these are all multiplied, correct? That's the only reason why I can do that. And then what happens? Left side equals right side is what people will say. But can a toddler say this looks like this? A toddler can reason through this canceling off that they match. Can a toddler do that? No, not a chance. Most of you can't reason through that. So until this point, which you have so much knowledge, now you're golden, but you're going to go 1 minus cos x times cos x all over sine x. It still doesn't even match that one. I'm going to rewrite this one to match it. 1 minus cos x, cos x. Your test and your diploma is not the time to save pencil lead. Like if you're like, oh, well, they can reason between this one and that one. Not the time to save pencil lead. I would write it again. So let's see. Yeah. There'd be no point. They match.
Okay. But does it matter if you want like further?
No, but you just, yeah. The more, like, that would be a time to stop wasting pencil lead. Don't distribute through. And the reason why is because what happens with people is sometimes they'll go too far, and then you actually end up making an error. Like, you'll go distributing now, and then you won't write the squared on the cos or something like that, or you'll distribute silly. And then you make an error in the math of the distribution, but they already match, so stop. Like, if they match, be happy and just move on. Yeah. Okay, you guys are going to try this one. And then we're moving on. Sine x cos x. Nope, that's what I just did. Cotan x over 1 minus sine x. You're proving this. Equals 1 minus cos. Nope, that's it. 1 sine x. Struggling. I'm struggling. Picking the wrong example. Sine x cos x. Yeah, try that one out, and then we're going to do addition and subtraction. Would you have to go the route I went?
Yes.
Not really. You could have multiplied this side, the left side, by 1 plus sine x, couldn't you? And make it match the other side. Both would work. Okay. There's no word for me to extend. I really want to send that somewhere. I don't know where I was going with that, but that's a 6. So we're going to do sum and difference first. These are your sum and difference formulas. They're on your formula sheet. But we're going to write them out so that we understand them. So we're going to write out one formula, then we're going to use the formula. Then we're going to write out one formula, then we're going to use the formula. Now, the reason why these sum and difference formulas come into effect is 2 reasons. We'll go through the first one. If I ask you for the exact value currently, I can only ask you for the exact value of any trig ratio directly off the unit circle with 30s, 45, 60s, and 90-degree reference angles, correct? That's it, because that's all, and 0, because that's all that you have exact values for. But remember, the unit circle has a whole bunch of different values you could pull off it. Like if I asked you for cos at 151, you could just go cos 151 into your calculator degrees, and you get an answer, and that would be the x of the coordinate on the unit circle, and then sine of 151 would be the y, and you'd get me an answer, but it wouldn't be an exact value, it'd be a decimal, correct? So the exact values currently that I can ask for are only 0s, 30s, 45s, 60s, and 90-degree reference angles. But what if I ask you for 15? 15 isn't on there directly, correct? But its friends 45 and 30, or 60 and 45, or 150 minus 135, that would be 15 as well, correct? So there are exact values on the unit circle that we could use by sum or a difference of 2 of them that would get me exact values. Okay? So that's what the sum and difference is for. To get us more questions, because why wouldn't we want more, that I could ask you the exact value for. Okay? So the first one we're going to look at is sum and difference of a sine. So we'll do the sum first. Sine of A plus B equals sine A cos B plus cos A sine B. Now that's how it's shown on your formula sheet. It's the top one of all those long ones. So the sum and difference ones start here. Here's your sine sum difference, cos sum difference, tan sum. Okay? Now, what I like doing personally is I like knowing that sine A is a value. Like this would be like sine of 30. Sine of 30 is a half, right? So I would plug in for sine of 30, a half. So I always like putting these in brackets because I know that each bracket is going to be replaced with something. The whole bracket, right? So, what one could we use? Give me an example. I want sine of something, then when I add 2 things together, they're exact values off your unit circle. So they have to be one of the numbers. So like, my example that I'm going to give is sine 75, because 30 and 45 is on the unit circle. I don't want that one. Give me a new one. What's another one? It has to be something where you add the 2. Yeah?
Sine 245.
That one's nicely on there. You're way too kind. I know where you're going, but no. He was going to use 2 exact values and then just decide what. I see you. That is not wrong, but it's a loophole. I don't want a loophole one. What are you adding together? And 30. So we could do sine 255. I would have went with like 60 plus 45, which is 105, but I like how you're thinking. Okay, sine 255. Now, how would you know to do this? If I just said sine 255, you could literally go into your calculator and do that, correct? Sine 255. But I'm going to ask you for the exact value. This is my example. Exact value. I don't know why I put a comma. I can't undo it. It's staying. It's squiggled. Okay. Exact value of, I've never been noted to be a fantastic English person, okay? Sine 255. So it's going to scream, do this, because it says exact value, and exact value screams, go to your unit circle for the most part, in trig. And I go, oh goodness, 255 isn't on it. But what friends of it are? Sine what? What friends were on here? You tell me. 225 and 30. Now, does it matter which one I list first when it's addition? No, do the commutative property. 225 plus 30 and 30 plus 225 is the same diff. Yeah? Okay. I'm going to match them up with colors here. I'm going to use a highlighter because I don't rarely get to. Okay. This bad boy here matches with this bad boy here, correct? 225 matches with the A. We following? Yes. So wherever there is an A in this formula, I'm going to put what? I'm going to put blue. I'm going to put, yes, I'm going to put blue, which is true, not incorrect. But I'm going to actually put 225, and then 30 is in the spot of B, so I'm going to put that in for B. Now this is something to note, please, paying attention. Do you see this plus sign? It matches the plus sign. So it doesn't go with B. Now in this case, you're fine with a plus sign. But when it's a subtraction sign, you'll be like, say, 225 minus 30. People will take the minus sign with this. It's not. The plus sign is the addition formula, correct? So what's in front is your A, what's behind the symbol is your B, and the plus sign means I need to go use the plus sign formula, which has a plus sign in the middle of it. The minus sign formula has a minus sign in the middle of it. Cos is actually opposite. The cos plus has actually a minus sign, and the cos minus is plus. You just have to follow the formula that it matches. Okay? So really, all we care about is what's in A goes in for the A's, what's in B goes in for the B's, and the plus sign tells me which formula to use. Make sense? Okay, so let's fill it in. So it's going to equal sine of A. A in this case is 225 degrees. Then we have cos of B, cos of 30 degrees, plus cos of A is 225 degrees, and then sine of B is 30. Then we have to go to our unit circle, or our brains, wherever this is locked. So, formula sheets and unit circles are going to be here for life for your friendly usage of Chapter 6. Sine 225, I know 225 is 45, so it's root 2 over 2. Because in quadrant 3 it's negative root 2 over 2. What's cos of 30? It's just the x at 30. Cos 225. And then sine of 30. Now what's great about the sum and difference formulas is you should get common denominators after this point. If you don't, you messed up. Try again. Something is wrong. Okay? Also, if you're like me, I had to get out of this habit. It's like common denominators, so I'll just catch myself going negative root 6 over 2. You have to watch yourself because it's actually 2 times 2, which is 4. Okay? It's not a common denominator. You're multiplying. So you're going to get negative 1 times 1, so negative 1. Root 2 times root 3 is root 6. We taught that last year. Multiply what's in front by what's in front, under by what's under. So coefficient by coefficient, radicand by radicand. And then root 2, or 2 times 2, sorry, is 4. Plus negative 1 times 1 is negative 1. root 2 over 4. Now we have a common denominator, so we can just write it all over. Negative root 6 minus root 2 over 4. Can I reduce my radicals at all? No. It usually goes really well to this point, if you get to this point, and then people start doing some crazy stuff. They're like negative root 4, and then it's a 2, and then it's, I'm like, stop. It's just boxed. Don't do any more. You can't do anything else. That is the exact value. Now, what's great about these questions, you should be able to walk away knowing you were right, or come back and cry a little bit and start over. Because this is the exact value of what? Sine 255, and I can find sine 255. Go to your calculator, type in sine 255. In what mode? Slap your hand first. Degrees.
Wow, look at that.
Then type that bad boy in your calculator and you should get the same thing. The chair. So when you type this into your calculator and you type in sine 255, the decimals should match. One is a decimal form, one's an exact form, correct? They should match. If you're someone who thinks you're going to never ever learn this and then just go math, enter, and it'll miraculously turn it into this, it will never happen. Okay? Not happening. Ain't happening. All right. So we're going to do this, the difference formula for this one. So we have sine A minus B equals sine A cos B minus cos A sine B. I want you guys to do the example for determine the exact value. Of sine 15. And I'm not telling you which ones to use because there's options. So I'm going to pick sine 45 minus 15. Minus 15. Good call. 30. You could have done 60 minus 45. There's a whole bunch that you could pick, right? Throughout the whole unit circle. I'm picking these two. Now, this is my A, this is my B, not negative, correct? The negative sign tells me I need to use this formula here, which is sine of A, which is sine 45, cos of B, which is cos 30, minus cos of A, which is 45, and then sine of 30. You have to stop yourself when it comes to a test and not try and distribute this sine through. People will go sine 45 minus sine 30 or something like that, or sine A minus sine B. You can't, it's not a distribution. You can't do that. You have to use the formula. So when you see sine, cos, or tan with something minus something or something plus something angles, that screams go to your formula sheet immediately and pull the formula off. If you can get the formula off, most people will get this question correct. But most people will actually just distribute or try right away off because you're just so addicted to distribution and distribution. Not mine. I've only taught you this year. Okay? I'm going to blame grade 6. Yeah, that's when you started. It was with multiplication. You did like, grade 6, you do like 6 outside of like a bracket. It was all numbers. There wasn't a variable existed. Don't you know? You learned bed mass. Yes. Yes. You learned bed mass. Well, then I blame your grade 4 teacher. No, I'm just kidding. All right. Bed mass is when you start learning about distributing. All right.
Forget about the S. So we use my S for a while.
See, then you weren't. You can't blame grade 4 because the distribution comes in when you have the pup or the bug. Okay. Root 3 over 2 minus root 2 over 2 and 1/2. So you're going to get root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 all over 4. Make sense? So it doesn't matter what formula I give you, it matters that you use the formulas correctly. And what is in for A goes in for A, what's in for B goes in for B. The minus or the plus sign just tells you which formula to use. Correct? That doesn't affect your A or your B at all. Okay? Here you go. Yeah. Cos. Determine the exact, oh my goodness. Determine the exact. Yeah. Exact value of cos 13 pi over 12. You can turn it to a degree and then stop rounding me. Okay? 3 pi over 12, 13 pi over 12 worked out to 195. What can we break it down into?
5 pi over 6. 5. That's what I said.
Okay. You all should know if you did this right or not. You type that in radian mode. You type your answer in, and they should match. Okay? Okay. All right. So we have cos A, cos 5 pi over 6, cos B, cos pi over 6, minus sine A, sine 5 pi over 6, cos A, and by that I mean B. Ah! Dirty, rotten. Okay.
That's what you have the whole time. Don't worry.
It's totally what I had the whole time. I don't care if you go back and rewind this.
It was always
Magic. Okay, 5 pi over 6 is negative,
negative root 3 over 2.
and then cos of pi over 4
Root 2 over 2.
minus sine of pi over 6,
1/2.
cos of pi over 4.
2 over 2. Is there any other way to do it? The way I did it.
Yeah, there's a whole bunch of other ones. So you get negative root 6 minus root 2 all over 4. Now pretend. A little life ruining. Welcome.
Would there be a way you can do it too with subtraction?
Yeah.
And you'll still get
Yes.
it.
Okay. Tan 75. Quiet, please. Shh. Tan 75, welcome to a lot of work. Make sure you have space. Don't start this at the bottom of a page.
Oh, wait.
Sure. Okay. The reason why I said don't start at the bottom is tan additions and subtractions, sums and differences are fractions, right? The formula is a fraction. So we need to do tan 30 and 45, or 40 and 5 and 30, doesn't matter. That's what I'm choosing was the plus, but you could go a minus 2. So it's going to be plus is tan A plus tan B over 1 minus tan A tan B. So it's tan 30, tan 45, I think it's plus, isn't it? Over 1 minus tan 30, tan 45. Now, I always do them off to the side. Tan 30s are what? Do you remember? Root 3 over 3. And then 60s are just root 3s. Now, if you don't remember, tan 30 is sine, which is a half, divided by cos, which is root 3 over 2. So I get a half times 2 over root 3. These cancel. So I get 1 over root 3 and rationalize it. It's root 3 over 3. So all tan 30s are root 3 over 3s or negative root 3 over 3s. All tan 60s are just root 3s. Cotans are the opposite because it flips it, right? So cotan of 30 is your root 3's, and then cotan of 60's is root 3 over 3. Now, keep in mind, you want to try and pick the one that gets you a root 3. I didn't. I picked 30. Okay? If you can go any root with tan and pick not a 30, go that way. Because it immediately throws you fractions. Welcome. Here you go. So, tan of 30 is root 3 over 3. If I could have used tan of 60, it would just be a root 3 and I wouldn't have a fraction, right? I didn't have that option, so I'm doing this. Tan of 45 is 1 over 1 minus 1 times root 3 over 3. So I'm going to get root 3 over 3 plus 1 over 1 minus root 3 over 3, which is a lovely answer, but it won't be the answer. No. There's plus or minus signs in here, so you're going to have to make, you can't flip your denominator until you have full fraction divided by full fraction. Yeah.
Are you going to stack the fractions like that?
No, which is where I'm going right now with this. All right. Sassy McSassy pants. All right. Root 3 over 3 plus 1 over 1 minus root 3 over 3. So, the moment you start stacking, you should stop yourself, slap your hand, and say, no, don't stack. Well, that's a problem. Be gentle. Okay. So, do we have full fractions currently? No. And David is right. We should write them sideways, not stacked, because that's stupid. Stacked is stupid. Go together. It's like stupid squared. All right. So, we are going to multiply this one by 3 and 3, and then multiply this one by 3 and 3. With the minus sign, it looks like a multiplication. So I'm going to get root 3 plus 3 all over 3 divided by 3 minus root 3 all over 3. Now what do I have? Full fractions, so what can I do? Flip them. So I can go root 3 plus 3 all over 3 times 3 over 3 minus root 3. These 3's can cancel, but don't go trying to cancel anything off the other ones. The other ones have plus and minus signs between them, correct? So they're connected. The only way they can go anywhere is if they actually have replicas on the top and the bottom to cancel them off. So we have root 3 plus 3 over 3 minus root 3. We've been living for this moment in time since grade 11. We prepared for this moment. Yeah, we have to multiply by a binomial with an opposite sign to get the denominator to go away. So we have to multiply by the conjugate in order to get your denominator to go away. This was a lesson in grade 11 for this very moment. So, we're going to multiply by 3 plus root 3. It's called multiplying by the conjugate. So it gets rid of the radical. So we're going to FOIL. So we're going to get 3 times root 3 is 3 root 3. And then root 3 times root 3 is 3. 3 times 3 is 9. 3 plus root 3 is 3 root 3. All over 3 times 3 is 9. 3 times root 3 is 3 root 3. Negative root 3 times 3 is negative 3 root 3. What do these two do? They cancel. And then negative root 3 times negative root 3 is 3 plus and back. I was trying to be aggressively fast. Minus 3. Wow, it's as if I said. Make sure you have lots of space.
Look where I started. Don't give me that.
Well, you could have. You started underneath the. So we're going to get 12 plus 6 root 3 over 6. And then this is the last thing we have to do. Yeah, it's a triangle thing. If you can take it out of all three, it's a 3 for 1 deal. If you can take it out of all three coefficients, you can. If you can't, you can't. So 12, 6, and 6. Can I take something out of all of those? Larger than that. A 6. So if you go 2 plus root 3 in your calculator and you type tan 75 degrees in degree mode in your calculator, they should match. Good answer.
Good job.
That's the homework.